So here we are once more. In the last video we've built the 32-bit register. By the way, I bought this and I think it's gorgeous and I'm wearing it for the video. So where have we been? We actually the level gives us instructions down there. Let's see if they advance. Set the value to 4. Yes. Linked component 0 should point to a register. Custom. Oh, now we have to link them. Let's see if we're actually allowed to do it this way. We will figure it out. I mean, in theory, if we remember this correctly, the game actually asked us to do 6 and 7 for outputs and counter. Actually, yeah, link component 6 should point to the counter. Sad. We can change this later. It's not like this is gonna stay like this forever. So here we are. We can relink these. Set up registers and implement the add code. So registers are set up, right? How do we... This is not readable. Interesting. Okay, so argument 1. Remember the colors. You go right here. Next one. What was argument 2? It goes to this one right here. Now the result, which is blue, goes right here. And now set up registers and implement the add code. I guess since what color did this have? It was purple, right? Let us have a look at the screenshot again. Oh, what happened? It was red. Only the result was purple. Do we even have red? Yeah, we have this color, more or less this color. So put it here. So now the ALU is feeding off the opcode. It is feeding into the registers. The next thing we're going to do is we're going to feed our arguments into the ALU. It's the wrong color. These are very close. So, okay. Now this looks exactly like this one, right? Actually exactly like this one. Maybe we could space these a little bit so it would look even more like that. I guess we're actually going to do it. Put it right here. Put this one here. One deeper. And we have a similar spacing to these, even though these are still wider spread apart. It's actually quite nice that you get these step-by-step instructions by the level. Really. Set the registers and implement the alpha. Yeah, I did that. Interestingly enough, we would have to be able to address the output and the input. Which I forgot about when building this. That means that we'll have to modify it. Because the way it is built right now, we are not able to send anything to the output or get from the input. We would have to put this in this. Interesting how this one and this one are both like addressable or need activation. Need to be disabled / enabled. So we would have to take care of this as well. So first of all, we're gonna step into the component factory. And since they sit on top, right, we will do it like this. Not very nice, not very neat, but yeah, this is how it's gonna be for now. Argument 1, argument 2. So if either one of these arguments is the input, this is the color for argument 2. Well, this is the color for argument 1, right? So the game wanted us to use 7 for this. And I mean, we can change this later, since we are able to define our own opcodes. 1, 2, 3, 4, 5, 6, 7. This one. We can just keep the link to the registers. It won't matter. Or we are going to need to be able to address them. Maybe we shouldn't. Maybe it's actually not the best. Not the best idea. Wasn't the best idea to build the register like this, because if we do it like this, we will, oh no, it's great. Actually, it's amazing. We will need to be able to address the counter as well. And yeah, I'll figure out a way to work around these components later on. So here we go. Counter. And once more. Counter. This should be correct. I feel like. Should I get to the correct component? Here we are. The input is going to be an input. Rather than an output. Or not an output. We're going to name these, even though since the component is so big, it is hard for us to read it when we are outside of the. Start it around like this. Still gonna be useful just because of the legend of on the left side of the component factory level. Going to write these ones not capitalized so we can distinguish between the two. Oh, by the way, this decides the orientation of the label, right? Which makes a difference in how it is displayed when we view the components like that. There it is. It defines the definition, the orientation of the label. Now yes, it's our ALU, and like because this component is small, we can read it without problems. This component is big, so we cannot read it all. Let's turn this one around as well. Here we are. We have two. Now we're getting into trouble. Because now we actually need to modify stuff. Argument 1 is yellow. We're going to feed it into, feed it directly here. Respectively here. Yes. we're gonna have to flip these switches around as well. And we want to address them. Oops. Our output can always, like, it can never only be the result, right? That is 7. No, this is the counter. So yeah, it can both. It can be both at the same time. And you don't feed off these, but instead you feed off the result line. And once more, since we already drew this line, yeah, I think that should work. We will also have to have a way to write to the counter. So we need another 8-bit output component. Which as well feeds off. Wait a second. This makes it so that we can take the value that sits in the counter as an argument. Maybe we might want this in the future, so let's keep this. I didn't intend to build this, but now we have it. Just read to the counter. It's not write to the counter. This is read from the counter. So you decide if we take the counter as an argument. Whilst you, we need another one for this to work. This one is the one that the level demands us to build to be solved. This is the one that lets us write to the counter. Not sure if we actually need this switch. Guess not. And here we have it. Since this one is gonna determine if we write to the counter in any case. So yeah. This right here is cool. And what did I say? What did I say earlier? We need to deactivate. But do we really though? What are you about? You're about input. If we take the input as an argument, we would have to make sure that the sevens, because this one is exactly this one. The sevens would have to be taken out of this system for now. Because elsewise we would have two arguments. Yes. And that would make a circular dependency. Circular dependency, the output of a component leads back into its own input. Alright. So yeah, I wanted to avoid exactly that. So how come? Why do we have 2 times arc 2? And this is because this is... This is the output. Would be a lot easier if we just copied this whole thing instead of using the custom component. Place it into the level. And build it like this. And the reason for that is that we can actually trace the circular dependency in that case. Also, I don't know, it looks, I guess it looks cooler if we... I think the game might have crashed. I think the game might have crashed on us. No, it didn't. Maybe it actually did. I mean, the level is called Wire Spaghetti, right? So it's gonna be... like all hell. Because of this. Okay, I'm gonna have to... Yeah, I guess I'm gonna make a cut. This and... see you in the next...